There's a strange and fascinating pattern that appears across ancient agricultural sites, whether you're looking at early Mesopotamian fields, Bronze Age terraces in the Mediterranean, or the highland plots of early African and Andean farmers. Wherever ancient grains were grown, the soil beneath them tended to stay fertile for far longer than in modern crop fields. Archaeologists have uncovered planting zones thousands of years old that still hold structure and organic matter, while modern farmland collapses within a few seasons without heavy fertilizer input. This isn't nostalgia or romanticism. It's a measurable difference rooted in the biology of the crops themselves. When these ancient grains grow, they rebuild the land as they feed the people. For the next minute, consider what this means. Before synthetic fertilizers and mechanized farming, civilizations had only one reliable tool for soil renewal: the plants themselves. They selected varieties that didn't just produce food, but also held the soil, fed it, shaded it, and restored what the harvest removed. Many of those grains have since been replaced by modern high-yield varieties bred for speed and uniformity rather than soil health. But the original grains still exist, and when gardeners and farmers reintroduce them to depleted soil, the results are astonishingly fast. In just weeks, you can see microbial life return, earthworms reappear, and dead ground begin to breathe again. The reason ancient grains outperform modern seeds begins with their root systems. Modern cereal crops are bred for predictable fields and mechanized harvests. Their roots are shallow, compact, and optimized for fertilizer-fed agriculture. Ancient grains developed under stress. Their roots dive far deeper and spread more widely, shattering compacted soil and pulling nutrients from layers modern varieties never reach. Einkorn, emmer, spelt, teff, millet, and heritage barley all possess root systems that act like natural tillers. When planted in poor soil, they break apart hardpan and allow water and air back in. This is why farmers in the Fertile Crescent and North Africa could maintain dryland agriculture for centuries without depleting their fields. They weren't relying on luck. They were relying on the architecture of the grain itself. These grains feed the soil because, well, they release far more carbon into the ground than modern cultivars. Root exudates are, microscopic sugars, proteins and compounds that plants push into the soil to communicate with microbes. Ancient grains released dramatically more exudates than highly modified modern cereals. This is why soil around ancient grain fields often develops the dark, rich appearance associated with thriving microbial communities. Early civilizations didn't understand the biochemistry, but honestly, they observed the results. Ancient Egyptian grain rotations always included emmer for its soil-building properties. Highland Ethiopian farmers still rely on teff to revive exhausted plots because it rebuilds fertility while it grows. The grains were chosen not only for yield, but for the way they restored the land itself. These grains also produce far more biomass, which becomes essentially free organic matter. Unlike modern dwarf varieties, ancient grains grow tall and produce thick stalks, wide leaves, and dense tillers. When these parts are cut down or left to decompose, they become organic matter that binds soil together. This was, in fact, a cornerstone of early European and Middle Eastern agriculture. After harvest, farmers cut the stalks and laid them directly on the ground, allowing the material to break down naturally. In dry regions, straw mulch protected the soil from erosion. In wetter regions, it fed earthworms. This simple practice is what allowed food-growing cultures to farm the same land continuously for hundreds of years without stripping it bare. A modern gardener can, replicate this by sowing small patches of ancient grain on tired soil. Once the plants reach maturity or even partial maturity, the entire stand can be cut and laid down as mulch. Within weeks, the soil softens, darkens, and becomes far more workable. The most powerful application is to use ancient grains as rapid cover crops. Planting ancient grains isn't just about harvesting them. They work exceptionally well as short-term soil rehabilitators. A gardener working with dead, compacted ground can broadcast einkorn or hull-less barley, water once and walk away. The grain establishes quickly, throws deep roots, shades out invasive weeds, and begins pumping carbon into the soil. After 4 to 6 weeks, you can cut it at the base and leave the roots in place. The underground root network decays into tunnels that improve drainage and aeration. The surface biomass becomes a blanket that prevents moisture loss. This technique was widely practiced in early agrarian societies that didn't rotate fields for fallow years. Instead, they used grains themselves to perform the restoration. Modern soil science now calls this a biological tillage system, but ancient farmers simply saw it as good stewardship. These grains survive where modern seeds fail because, they evolved under harsh environmental pressure. Ancient grains grew in unpredictable climates, poor soils, and rugged landscapes. Over time, they developed resistance to drought, pests, disease, and nutrient scarcity. Modern varieties, by contrast, rely on an artificial environment, things like irrigation, precise fertilization, and controlled fields. When you plant ancient grains in tough soil, they respond by actually improving it. But when you plant modern grains in the same conditions, they just sort of stall. This difference is why ancient grains are still used in restoration projects across degraded agricultural zones globally. They don't just grow, they rebuild the ecosystem around them. And the fastest way to revive soil using ancient grains is through staggered planting cycles. A simple example is splitting a garden bed into thirds and sowing ancient grain in one section at a time. After each section matures, cut it down and let it decompose. Then plant the next section. This rotating wave of biomass and root activity produces noticeable gains in soil structure within a single season. Areas that were once hard as brick become friable and dark. Seeds germinate more reliably. Water no longer pools on the surface but sinks in. Ancient farmers created these cycles instinctively. Modern gardeners can recreate them intentionally. If you want more historically rooted methods, forgotten agricultural practices, and soil-building systems that outperform modern shortcuts, make sure you subscribe to Hydro Haven. Share this guide with someone who wants to rebuild their soil the way civilizations once did, from the ground up.